Like George had mentioned, my name is Jack Leach. I run a software development company here. We do a fair amount of Access work. We do a fair amount of ASP.NET work, mainly using SQL Server as backends for the vast majority of what we're doing. And as we try and transition away from Access web apps, we can try to utilize some of the same, at least database layer end of things, and see if we can at least reuse that portion of it and come up with some knowledge and experience with how to make the performance work reasonably well when we're working with a local client application such as the Access client. The performance on a remote backend with SQL Server and an Access client is not usually that good out of the box. Access was originally built based on working over a LAN, over a local area network, where things tend to be much faster, and Access is also a little bit on the greedy side as far as how it wants to use data kind of out of the box. But luckily we have fair amount of flexibility in what we can tell it to do and how we can look at things and structure things in order to come up with a good, reasonable performance. And the other nice thing about, I think, taking a look at database performance in terms of the more broad transition to replace the Access web apps is that the knowledge that we can gain from taking a deeper look into this is not only usable for Access applications itself, but can also act as a decent foundation for pretty much any database application that you might want to write. So with that said, we'll move into some of the stuff here that we're going to go over. First, we are going to take a look at just kind of getting grounded with some of the fundamentals, and that is going to cover a couple of three-letter acronyms here. The WANs, a wide area network, which you're probably familiar with. We have ODBC, which is the Open Database Connectivity standard, and we have a concept that I'm not sure how it's actually pronounced, but I call it rebar. It's row by agonizing row, it's called, and between those three things, they will form the foundation for the knowledge that we should have and what we should be thinking about as we are developing for this type of stuff. And then we'll take a deeper look at ODBC, and we'll move into how we actually how our data is structured in our applications and how we can classify it to handle it accordingly. We'll take a look at some actual techniques for how to handle that, and finally there's a little bit of a list of other things that we can just keep in mind as we go about things. So with that said, we'll start off with the first part of this here, which is just kind of getting a bit of a foundation underneath us, and we'll move into the wide area networks. A wide area network, as you're probably aware anyway, is just kind of a remote a remote network. It's not a local network, and it is really the fundamental basis of performance that we're going to see as we're doing this type of stuff, simply because we have to every request that we make to the database has to travel over a much wider area and a much less stable network in order to get to where it's going and then come back to us. And unfortunately, this is something that we have little to zero control over. It's very dependent on outside factors, and we can't always count on having a really good wide area network to work with. If any of you have been around for quite a while, you may have run into Albert Kalau's classic article on this, which I have a link to here, which goes into some detail about why this is goes into some depth of detail about why this is kind of problematic and how this is really slow. And I'm going to skip over a lot of that, what he has in his article there, but it is a good reference if you have a few minutes to kill. But the takeaway from that is that for every request we make to the database, it makes at least one round trip circuit in order to leave us, get to the server, and get back to us. And those round-trip communications are anywhere from 10 to 100 times slower than what we typically see over a LAN. So if you're used to working with access on a standard client-server setup within a local area network, there is a very significant performance hit when we start working with something remote like a SQL Azure backend. We'll move on to ODBC, which is Open Database Connectivity, and it is ODBC in itself is more of a standard. More of a standard than it is an actual tool. There are many implementations of ODBC. One of them that we will use very often with Access is the native client 11.0 driver, and that is based on the ODBC standard, and it is designed for working with SQL Server as a backend, and specifically with SQL Azure as a backend. So that is received very well by Access as well, and that is the preferred driver that we're going to want to be using. I believe actually there is a newer version, a 13.0 version, which makes some improvements. It makes some improvements on the resilience of the connections, but actually I don't have a lot of information on it prepared for this particular presentation. But in any case, we want to use the native client driver for doing access applications that are connected to a SQL Server backend. At its most basic level, ODBC, or the native client, acts as a translator between the two SQL dialects that are going to be in play. We've got the JET/ACE dialect of writing queries, and then we've got the T-SQL dialect, which is your transact SQL, which is the language that SQL Server uses and knows. And there is minor differences between them, and the ODBC driver, the native client driver, will act as a translator between those two in order to keep things rolling for us. At its fully functional level, it actually acts as more of a contract for your requests. And I guess what that means is that sometimes it can't just do a simple translation between dialects, and it actually has to perform some actions on its own in how it manages the data. But the native client driver, the ODBC drivers, will get us the data regardless of what they have to do in order to do it. So when we send a request, as long as it's a valid request, we can always kind of count on the fact that it will resolve that request, even if it takes it a long time to do so. So the ODBC's drivers first priority is to get us the data that we ask for, and its second priority, generally speaking anyway, is to do it in a performant manner. And we'll take a look at how a little bit inside of how it works in order to give it the correct instructions so we can do so in a reasonable time frame for us. So between the WAN and ODBC, there's those are really the two fundamental things that are in play here that really affect the performance of things. And we're going to go take a look at one more core aspect, which is what we call rebar, or row by agonizing row. And in order to understand why we may have a query that can take 2 seconds, or we can get the same data in a query that can take 2 hours, we need to understand how it is that SQL tries to work, attempts to work, and how it is that it could work in more of a worst-case scenario type of thing. So this term, it's not a formal term. It was coined by a gentleman, I believe, named Jeff Moden a number of years ago, but it's become a industry standard term. But the SQL Server itself, and just about any database engine, really, not just SQL Server, but also Access and all of the other big players out there, the SQL itself is really a set-based language, a set-based engine. It wants to operate on large sets of data at a time with single instruction sets to do things against this larger set of data and return those to us. So all of these operations are really optimized for that, and it's not really optimized to work on a single row by row basis. But if we give it the certain commands that we give it, it can't always resolve things on a set-based method, and it has to drop into this this kind of single row processing mode where it has to look at every single individual row that it needs to process in order to get us our results back. And this is so inefficient that it has been named row by agonizing row, because it's really not a position that we want to try and force our server into. So as we work through this presentation, we will be taking a look at some ways to try and make sure that we do not do this, and some other ways that we can actually look at it and do it fairly safely. But in any case, it's an important concept that we should understand in order to really kind of understand why performance can be so bad when we're working over a wider area network like this. So that's the three things that we want to keep in mind as we're moving forward and as we're designing as we're designing Access desktop applications that will connect to SQL Server. Now, with that said, we want to take a little bit of a closer peek into the ODBC driver, which is a difficult thing to do for me, at least, because this is really kind of a black box. We have trouble, most mere mortals anyway, have trouble understanding what it is the driver is doing and how even a database engine works, how it gets results so quickly, and what kind of what kind of things might make it not perform so quickly. So we're going to try and take a look into this a little bit. We're not going to go too much into depth because it's a topic for another presentation anyway, in depth, and not one that I am prepared to give. But anyway, we can at least go over some of the basic concepts of how it works and use that knowledge to better craft our applications as we build them. So the ODBC driver, as a basic translator, like I mentioned, we have JetAce SQL, which is your Access SQL dialect, and you have T-SQL, which is for SQL Server, and there's slight differences between the two. Even though the SQL standard is fairly well defined, there are relatively few database engines that actually handle it perfectly. So there's always some differences, and that's going to be the same whether or not we have an Access front end that is connecting to SQL Server, if we have an Access front end that's connecting to MySQL database, or MariaDB as it's called now. So there's always, with each database engine we use, there's always a few things that are a little bit different. ODBC is going to attempt to translate these for us, and if it can't do a direct translation, it's going to figure out other ways to get us the results that we need to do. So for each SQL request that we make, each query that we send over, each piece of data that we request from our remote server, the ODBC native client driver is going to take that piece of it's going to take that SQL statement that you give it. It's going to attempt to convert it into the SQL Server dialect. It's going to send it along to SQL Server, get the results from SQL Server, and then present the results to our local application. We can see some very we could take a look at different ways to do this, and I'll stop here for a minute just to note that these examples that I have in here are theoretical examples. It may not be exactly the way that the ODBC driver is going to convert these types of things, because again, the ODBC driver itself is really like I said, kind of a black box, and but we can see in general, get an idea for kind of how it handles this type of stuff. So what we have up here on the screen right now is a very simple SQL statement. It's a very easy ODBC translation. On the left side, we can see the Access dialect that we're using, which is should be pretty well familiar to most people, I think, anyway. And on the right side, we can see the SQL Server dialect, which is almost identical, except SQL Server typically needs to use a single quote instead of a double quote. So this is some of the very, very minor things that the ODBC will recognize and interpret and handle accordingly. It'll make that translation, and when it's received on the SQL Server end, it'll be fixed up so that SQL Server can understand it accordingly, and it'll give us our results back. We'll move on a little bit and take a look at a somewhat more complex query here. This query is going to select all of our companies that have at least 5 clients associated with them but have no locations associated with them. In this query, to read it, it looks to be a little bit more complex as far as us being able to read it, but from the ODBC end of things, it's really pretty straightforward. There's not much going on that it needs to do. It knows that it needs to remove these parentheses because that's not part of the T-SQL dialect, and it needs to replace the underscores with the dots that SQL Server is using. But otherwise, despite the fact that there's a lot more text in this query, it is a very simple translation still for SQL, or I'm sorry, for the ODBC to translate accordingly. So this is not really a problem in terms of performance. We move on a little bit, and we've got a seemingly simple SQL statement here, but one that ODBC is going to have a difficult time translating, and the reason is because we have a function in here, the NZ function, which is a function that is native to Access. It's both a VBA function as well as a JET function, but it's not something that the ODBC driver may understand. It's not something that SQL Server understands for sure. And ODBC may or may not be smart enough to interpret it accordingly. So if we pretend that ODBC doesn't understand the NZ function and can't make a direct translation, how then does the ODBC driver go about getting us its results when it can't make this translation? At this point, it kind of steps back from the role of translator, so to speak, and it turns into something that actually needs to take real action and says, okay, well, I know somewhat what they're asking for. It looks like they want to look at the companies table, but I don't know which records. I can't figure out which records they want to look at. So what I'm going to have to do instead is pull in all of the records from this remote data source into the local application so that we can perform this where clause accordingly, because we have the driver has no way to transfer that criteria over to SQL Server. And that type of even though it's a very simple query, that type of not being able to understand a direct translation is where we tend to start running into a lot of trouble with performance. Even this one is actually a little bit simple in terms of performance. It does need to pull in a lot of records and process the records locally, which is not that bad, but there's actually worse stuff that we could do. And before we get into a theoretical worst case scenario, I'd like to stop for a second and look at how another view at how the ODBC might handle something like this. So if we look at this variation on that query, we have a where clause on the access end that we're sending to it, where the company name is kind of hard coded in there, and that is something that ODBC can just forward right along to the SQL Server. And we have the NZ function up here in the select portion of the statement. And that's not actually bad that's not actually bad for performance, because the ODBC can send the request off and say, hey, I know we're going to need the company name field in order to resolve this function, but we also know that we can restrict these records per their request here. So we'll get this record set that is restricted, we'll bring it back over to the client for them, and then we'll process this part of it here. So that is actually not bad in terms of performance goes. So if we jump back a second and take a look at this previous slide, there is a really big difference in when we use a custom function of some sort in the where clause versus when we might use one in the select clause. In this case, in most cases, as long as we keep the criteria searchable, which is search argument able. It's kind of a fun term, I always thought, but as long as we keep the where clause to be able to be translated, and we keep any joins in the queries to be able to be translated relatively easily without having to kind of muddy the waters for ODBC, we can be relatively safe in including some custom functions up in the select clause itself, because these don't have to be resolved really until it gets the data back from there. Now, with that said, having taken a look at a somewhat difficult query for ODBC to handle, let's take a look at what could possibly be a worst-case scenario, so that we can see kind of why we might have a query that can take 2 hours or 2 days to run, when it can run in a matter of minutes on Access itself. So with this query, in the access portion of things, we have a fairly simple select statement. We have a companies that we're pulling it from, but then we have this inner join here, and we've got some more complex stuff going on in here. And we've also got, within this inner join, we have a custom function that is part of a where clause. And then we're going to go ahead and try and bind this to the outer query. We're going to have what's referred to as a correlated subquery, which means parts of the inner query rely on parts of the outer query. So this is, in terms of processing, it's fairly complex. So if you give this thing to ODBC, it says, what? I have no idea what you're trying to, I have no idea how to translate this for you. So ODBC is going to get us the results, because that's what it has to do first, but we want to take a look at how it's going to try and resolve a query like this, which is very difficult for it to understand. So I'm going to move on to the next slide here, and theoretically, because it's very difficult to know exactly what's going to happen within ODBC and within the server and how this stuff works. Theoretically, here's what it can do in order to do that. It can try and determine that it can't process the join server side. It can't handle this join server side, so it's going to want to pull some information back to handle it locally. It can't process the subquery server side, so it can't even get this information for us from the subquery as a smaller result set to process locally. It's going to have to bring all that back. It can determine that the subquery is a correlated query, maybe, but it can't really do anything with it. So what it may end up doing is trying to pull the entire companies table here for local processing. It's going to take all of those records and pull it back into the local application. So this is possibly a large data set that needs to come over a wide area network and land in our Access application so that we can start processing it. And because it's a correlated subquery, it's going to start trying to process that and realize that it needs more records. It needs to now process the subquery so that it can figure out whether or not this join is going to be okay. So it's going to look at the first record, it's going to attempt to process the subquery, it's going to see that it can't, it's going to pull that subquery table from the server all the way back over to our local Access application. It's going to resolve the join on it and see whether or not that particular record needs to be included in the final result set that it needs to give to us. And if it does, it'll store it. Otherwise, it just kind of discards it, and then it repeats all of those steps for every record that we have in the company's table. And when we start considering the fact that trying to do this over a wide area network, we're essentially telling the ODBC driver that it needs to make this, it needs to resolve this thing, but it may take 100 or 100,000 or 10 million different trips to this thing on a rebar type of methodology. It has to look at every single row in order to figure this out, and then keep going back to the server and then coming back to us, and keep going back to the server and coming back to us, and you multiply that by however many records you have in your base table, and then you multiply it by however many records you might have in your subquery. At that point, it can very well become a query that could take 2 days to run instead of 2 seconds to run. So that is a very, very important concept in understanding how the ODBC driver has to resolve these different data sources and different instructions that it is given in order to get us the result sets. I have a question here that says, would is not null instead of NZ make a difference in the where clause? And that is a good question, and that's exactly the type of stuff that we should be thinking about, because yes, that would make a huge difference, because if we jump back to where we were looking here, if we have is not null in there, that is a part of the SQL standard which would be understood by JET as well as by T-SQL. So if we were to use something more standard there, such as is not null, then we would expect to have much better performance than if it had to process the NZ function. So it's a very, very small thing that can have a very, very big impact, and that's the type of stuff that we definitely want to be keeping in mind as we are working through this type of stuff. In this example, yes, I believe that the ODBC driver actually is, the native client driver, I believe, is intelligent enough to convert the NZ function itself in there. So I chose NZ as an example because it is relatively familiar, I think, to most Access developers, and it serves as a good example of something that may not be able to be translated. And again, I'll throw out my disclaimer that trying to see exactly how there are ways to look at what winds up on the server end versus what we sent on the client end, and comparing the two to see exactly how it is converting, so that we could actually verify that. But that is probably not something I'm going to get into too deep in this. In this presentation. So the NZ example really is more of a concept-based example than a hard rule that, hey, we cannot use this. What I would like people to be able to take away from the example is that we need to be very careful when we are using JET, ACE, dialect functions or VBA functions within our queries, because they really can have a very significant effect. And because it is so difficult sometimes to figure out how ODBC is trying to resolve that, it is a good practice to err on the side of caution and say, if we can use a more standardized query dialect in order to be able to do this, we're going to be better off doing it that way. So hopefully that helps clarify things a little bit on that end and answer some questions. I'm going to skip back forward here to, so we looked at this, and some takeaways that we want to keep in mind when we're doing this is that ODBC's highest priority is really to get us results, and the performance is a secondary thing. So it will always get us results, even if it takes forever to do so. We need to try and tell it to do so in a way that it can do it quickly for us. ODBC can be pretty smart about how it does this, but if we give it something that it can't sort very easily, we're going to have to pay for it in terms of performance. When we are crafting SQL statements and when we're building our application, we should always keep in the back of our mind, how is the ODBC driver going to attempt to translate this? How is it going to attempt to resolve this? That is something that we want to be aware of, or at least have some idea of what it is that we're asking it to do. And we should also realize that JET-specific and VBA functions should, for the most part, be avoided, because we can't be sure, in many cases, we can't be sure which ones are going to be able to convert cleanly into SQL Server's dialect, or which ones are going to result in having to do a more complex comparison by the ODBC driver, which is where the severe performance problems come in. One of the other things that we should keep in mind too as we're working on this is that the fundamental database design and normalization can have a fairly significant impact on how effectively a query can be processed as well. It's another factor that we throw in there when we start thinking about when ODBC has to come up with all these different ways to translate and resolve these things, and we throw in some poorly normalized or not normalized data on top of that, it can really compound the issues. So there's a lot of ways that these performance issues can be compounded and make things worse and worse and worse. So it's important to realize that we want to try and keep this end of things as clean as possible when we're doing it, to make sure that everything is running as smoothly as it can. And the other thing to keep in mind is that the inner workings of ODBC itself and database engines and how they process this stuff is pretty much like black magic to most of us. I think very few of us, at least myself anyway, are very much in the dark about how the details of how this stuff actually works, and we wouldn't really expect application programmers or even database application programmers to have the knowledge of the inner workings of these types of things. So we want to approach this with a concept kind of approach. Like, these are the types of things that you want to look for, rather than very specific type of stuff, because it's the concepts that are going to kind of keep us afloat as far as the performance goes. So all in all, between the wide area network and the fact that it needs to travel so far in order to resolve our requests, the ODBC driver, and entering some sort of row by agonizing row methodology, between those three things, they are the core factors in performance that we should be keeping in mind. So with that said, we'll kind of move forward into the next section here, which is going to be taking a look at our data as we use it in Access, and trying to kind of get a perspective on our data and how the data is being used, and how the data is being used, and how we can classify it and kind of break it up into different classifications that will make it easier for us to make smarter decisions on how we want to source that data. So as we start looking at data, I've got here a fairly standard line of business form that is pulled up here. It's this application that we'll be taking a couple of screenshots looks at is based on a service company that could mow people's lawns, let's say. So it's a company that they have people that set up these recurring orders every couple of weeks or every week or however long. They'll come and mow the lawn at this house. These clients may have billing profiles set up. They might have cleaning profiles or lawn care profiles set up, and then they'll have orders and stuff that they need to be processed. So what we're looking at here should be a relatively, relatively simple, kind of straightforward form that we would expect to see in any given Access application. So what we want to do is be able to look at this and come up with different types of data and where the data is coming from. So different types of data so that we can kind of classify it and see how we can use it to better our performance. So we have three main types of data, classifications of data that we want to look at, and that is list style data, which is usually small sets of read-only data, very often used to populate like drop-down boxes, such as a preferred day of the week or order statuses, that type of thing. We have what I'm going to call primary data, which is our usual vanilla record sets, our day-to-day bound record sets. So when you pull up an order form and you see, you go to do your data entry, it's usually bound to a single table or maybe a query anyway. That's our primary data. There's not a lot of fluff to it. It's just basic data with a two-way binding on it, as we call it. The third type of data that we want to classify really is the results of some heavier queries and more analytic type of stuff, summaries, dashboards, reports, and this type of data is typically read-only. It typically involves a number of different tables involved in order to come up with this, a number of higher profile where conditions that drive this data, and they are much more susceptible to performance issues than something very simple like our primary data. So if we want to try and visualize where this data is coming from, we can see we have a list of orders here, which is basically a summary of orders, which has information. It's more of a complex query type of thing, which has information pulled from the orders table, the billing profiles table, which one they're going to be using, some information on where they're going to be processing, so which team is going to be doing the service work, that type of stuff. So this is a kind of a summary list of a couple of historic orders, some scheduled, and some future orders that are coming up. That is a fairly complex query behind this, driving this, because like we were talking about with the complex data, it's got a bunch of different data sources that it needs, and it's not something that is just very simple and straightforward to come up with in terms of sourcing the data. On the other hand, we've got in the blue shaded areas here, we've got what is our primary data, which is just a basic record set. We have one record that is being displayed at any given time, and we can kind of go through there and see that these fields are bound directly to it. Fairly simple, not much going on there. And then in the green, we have our list style data, which is drop-down boxes. Pretty much just drop-down boxes, really, like a preferred day a week, a frequency that they want to come in. Maybe they have a couple different billing profiles set up. I want to use this credit card this time instead of the other one, that type of thing. So the list data is the other thing that we want to look at. So when we're looking at a form like this, and we want to be able to pick out which ones are list data, which ones are our primary just kind of vanilla data, and which ones are our more complex data, because each one of these three different types of things we can look at differently to we can handle it differently to get better performance out of it. So when we start looking at this and thinking, where is this data going to come from, we've got roughly 15 different data sources in here in order to populate this fairly this fairly common type of form. Has got a lot of different data sources between all of the drop-down boxes, between the various different components that are on the screen. There's a lot going on, and if we figure that at least one of these is probably going to invoke that row by agonizing row type of query that we looked at previously, that's going to be problematic as well. If we also figure that each one of these 15 or more different data sources is going to be a separate request going to this remote server to get that data, which it is, we can guess that at very best we're going to have, if we just had all of these things bound directly to the to the server, we're going to have a very best, like maybe 10 seconds or so to open this form, and that's completely disregarding the really kind of heavy query underneath that could be particularly problematic. And that is 10 seconds to open a form is not something that we can cope with. That's not acceptable by any means. So we want to take a look at how we're going to handle each different types of these data. Along with the data classes that we went over, the list data, the primary data, and the complex data, we also want to try and consider how is this data used? What is the state of the data? Is it static data? Is it stuff that rarely ever changes? Or is it dynamic data, stuff that changes very, very often? Usually, your list data will end up being fairly static. Your primary data will change often, but we're working with a small subset, so it's okay. And a complex data is something that will change very often also. So for the most part, we can focus on what type of data we're working with, and this will kind of fall into place. But we also want to keep in mind when we start looking at techniques for handling this, whether or not it is relatively static data or whether or not it's relatively live data, so to speak. So with that said, we'll start getting into some techniques to how to actually work this stuff so that it performs well. And the core techniques that we're going to end up using here is really kind of caching data, storing it locally for the life of a particular session or shorter maybe. Some temporary data. Sometimes it may make sense to pull data into the local and into the local access application and then continue processing it there kind of manually so that we can avoid the rebar state that ODBC can drop into. And one of the other very, very helpful things for performance like this using a SQL Server backend is utilizing the SQL Server views, which is the equivalent, more or less anyway, the equivalent to a saved query in Access, but it's stored and resolved fully on the server, and also SQL Server procedures, stored procedures. And these are both methods of essentially letting the server do the work, which is extremely helpful in performance as well. So with that said, we'll start taking a look at these things in detail and see what we can do with them. We'll cover caching data first, which is it's an excellent choice for static list style data or really kind of any read-only data that is relatively small in volume. Stuff that doesn't change often, stuff that we can load into the Access application maybe at startup and not have to worry about it too much after that. It's a really good choice for this type of stuff because it's very easy to implement and it gives us very highly effective results, because if we were to cache all of the list sources from the form that we were looking at before, we would effectively cut out almost half of the data requests that would need to be made. So just by caching data, we've taken that form and cut it down from a 10-second basic load time maybe down to 5 seconds or so, which is certainly much better, even though it's still not going to be ideal necessarily. But caching data is very easy to do. It's relatively low risk. We don't have to worry about too much with it. It cuts out a large amount of the round-trip remote data request, and it's really kind of one of the most effective ways to improve form performance, because every time we open up a form, we usually have some sort of drop-down list. Often we have a lot of drop-down lists, and Access is actually very liberal about how it applies the data source to that drop-down list. So there's a lot of different things that you can do within a form and Access that will cause that to requery those things where we wouldn't really expect to. And when all of a sudden it needs to requery 10 different drop-down forms from a remote source, it's going to have a pretty severe impact on the usability of our form, because it's going to be tied up trying to make those requests. So we would bring that data in locally, and it solves a lot of problems. Ideally, we do this in in kind of a standardized method. I have in many applications, actually in any application I have that uses a remote server, I'll have a function similar to this one that you can hopefully read on the screen here, which basically just takes a table name. It assumes that there's a naming convention that maybe just throws cache onto the end of the table name, and it also assumes that it's got more or less the same fields in both tables. So if we set up a local table, a local cache table, and we have a remote table, and they're pretty much the same as far as structure goes, it becomes relatively easy at that point to set up a nice and reusable single function that we can use to kind of cache this data. So the method that I have found that actually works very well is what I refer to as a dual record set approach. It actually opens up a record set object against the remote backend, and it opens up a record set object for our local table, and then it just proceeds to go through and it actually loops row by row, which is not something I previously recommended, but I'll get into why this is a little bit faster in a minute. But it'll actually loop row by row and just go through and write the data from the source into the target table. So it moves all that data for us into a local cache table and cleans things up from there. And then we've got a nice a local cache of data that we can work with. We can further this type of reusability by just being a little bit more creative with how we set up our code for it. In most of my applications that deal with this type of stuff, I will have a public enumeration which just lists the tables that we might want to be caching, and then I'll have a public refresh all method which will essentially just cache everything that's listed in there, and I will have a refresh method where we just tell it, via this enumeration what we want to do, and at that point it becomes very easy from anywhere else in the application whenever we may want to say, hey, I need to refresh this cache because I just updated a kind of a static. Maybe I added a new type of frequency into when these people are allowed to set up their lawn care type of stuff. Doesn't happen very often, so it's still a good candidate for locally caching, but you do want to have the ability to say, hey, I need to refresh that cache table on demand, and it would just call this previous function and clear out the local cache table and run that again to repopulate it. So loading the cache data on startup is typically what I prefer to do. It increases the application startup a little bit because we're going to load up a bunch of data when we start up, but it improves the runtime performance of the application once it's started pretty dramatically. So the trade-off on doing that, I think, is not bad at all. I have found that a surprisingly large amount of records can be transferred in a short period of time doing that. We have some applications where we load anywhere from about 10,000 to 300,000 records into a local database every time it is started up, and it is done, I think in a worst case scenario, it takes like 8 seconds or so in order to do that using this dual record set approach, kind of as I've shown. And the difference between using this type of dual record set approach and the row by agonizing row is a little bit it's a little bit subtle. It's not very clear when we're looking at it, but this actually does perform pretty well. And the reason being is that the source table that it is pulling from on the remote server, it doesn't have to do a lot of complex processing on this. It just needs to open up a record set, and it's actually going to pull in the data in pages, as it's called. It's going to pull in the data in pages, so even if there's a lot of data, it's going to pull in a good-sized chunk of it, and then we're going to process it and write the values into our local table, and then it'll get another good-sized chunk of it, and we'll continue to do so. So even working with a source table that has a large amount of records in it, it can still be faster than we might expect to handle it on a row-by-row basis like this, and that is because we are not telling it to really resolve anything, so to speak. The request that we are submitting to the ODBC driver in order to process that is very simple. We're just opening up the table directly, and that is really kind of the difference between doing something like this versus throwing a complex query at it where it needs to process different things, needs to process a whole bunch of different things in order to resolve it correctly. So the other thing that we can do, and I'll skip by this pretty quick, is because because I'm taking a little bit longer than I should, but an incremental cache loading. So if we have, let's say we want to load up a cache and it's kind of a large data cache, and we don't want to load it every single time, but we only want to load what has changed since last time we did it. We can include a date modified on the server record, and we can include a somewhere locally we can say, hey, when was the last time we cached this data? And then our source query for that is still fairly simple, because we just say get it from the source table where the date modified is greater than that, and go ahead and update only those values. So the source query is still very simple. It performs well. We can use a more advanced caching method like that, relatively safely still. One of the things that we may be tempted to do is to use some sort of frustrated join to update non-existing values, or possibly to use an append query like was just asked in the comments there. And one of the reasons that we really want to try and avoid doing that is because this puts us into what we call a heterogeneous query state, which is where a single query needs to look at both the source table and the local table in order to perform the action that it's being requested to perform. So even though this query is a fairly simple query, we're telling it to insert into a local table sourced from a remote table, and now we have one set of instructions, so to speak, that involves two different tables and two different servers. And ODBC doesn't quite know how to do that very, very well, so it takes the safe route and it drops down into the rebar comparison in order to do that. So generally speaking, we want to try and avoid these types of queries where we might have two different sources that are kind of being used at the same time, because that can be very, very bad for performance, because it ultimately goes into this rebar mode in order to resolve it. I'm going to jump back real quick here to the add new in the first example per Phil's question here. So yeah, if you want to give me the question there, I'll see if I can answer it quickly. Or what I can do is, see, we were pretty much done with caching the data there. So we can hold that question until we get done with the rest of it and come back to it. Where am I? Sorry, I'm here. So that's essentially all we need to consider working with caching data, and again, it's a very simple and effective method of getting data into the database so that we can work with it from there on out without having to really worry about it too much. The next thing that we want to take a look at is really working with the primary data, which is our day-to-day record sets and our detail edits, and this is actually pretty straightforward. There's not too much that we need to worry about. The only thing really for consideration is that what we do not want to do is we don't want to give the form a record set that is bound directly to the table and says, give me all of the records that are in there, because then we're asking for a lot of data from the server. So if we used a detached record set, basically, we go ahead and do our development based on the record set, but before we start testing performance on it, we can actually remove that record set from the property and then use the load event of the form to say, hey, give me only that one record. I only want that one record. And as long as we are using only that one record, which Access will actually figure out and do on its own sometimes, but it's always better to be explicit, I think. But as long as we're only using one record to handle our primary data like that, things generally go very well. And the really nice part about that is we can continue using our regular binding, with a DAO record set object underneath it, so we don't have to go screwing around doing funky stuff in order to support this type of just doing regular detail edits. The only other thing to mention really here is that when we're looking at one of these things, we definitely do want to strongly prefer to bind all of our combo boxes and list boxes to a local cache data set, as we were talking about previously. And that's about all there really is as far as primary data type of stuff goes. So we can move on here and say, what are we going to do about this complex data where we have this really complex query that we need to use? Stuff that we're going to see on summaries and dashboards, or a friendly list, kind of as is shown here, for reporting or exporting sometimes. These queries that take a lot of processing on the back end in order to work. A couple of characteristics of them: they're almost always read-only when we're doing this type of stuff. Very rarely do we ever have to have a writable complex query, which will help us considerably, as we'll see shortly. And also that there's usually multiple tables, numerous joins, and fairly extensive criteria in there. And basically what we want to do with this is leverage the server-side processing as much as possible in order to we want to be able to give this query to the server and say, here, do whatever you need to in order to get me this result back, but please don't send the result back until it's at least almost complete, because I don't want ODBC to have to really screw around trying to resolve this, because it's going to take forever. If we do need to do something to it on the local end after it gets back to us that we cannot have the server do, at that point it's better maybe to request a base data set and pull it into our local application, and then put it into a temp table and process it from there, and that avoids that type of query where we have a source that is in the server and also a source that is on the within the same query on the local end, because that can be a very very bad thing as far as performance goes. So essentially we want to tell the server to do everything it can and go from there. So there's two ways that we're going to be able to do this. We're going to work with views, and we're going to work with stored procedures to do this. So a SQL Server view is essentially it's kind of the equivalent of a saved query in Access. So we're going to create a view, and we're going to give it a definition that is any valid select statement, with one minor exception. And then from there, once we create that on the server, which is something that we actually couldn't do directly in an Access web app, but if we're going to take control of these databases, we should have the permissions to be able to go in and do this. But once we create that view, we can link to it as if it were any other table within Access. So it becomes usually read-only, but it becomes a good way to let the server handle some of the heavy processing. So I've given two kind of very basic examples anyway, and views can be much more complex than what we're showing here, but essentially we just tell it, create view with this view name, and the statement that we're going to run for it is right here, and then we can link this myCoolView as a table into Access, and then we can say, hey, okay, give me this field, that field from this view, where whatever, and we can order it accordingly and do things accordingly from there. So that's a very powerful way to let the server go ahead and process that type of stuff. The one thing that a view cannot do, well, two things that a view cannot do. The first one it can't do is you cannot put a sort order in here, which is not too big of a deal because we can always kind of do that from the Access end. But we also cannot parameterize a view, at least not very easily anyway, not within the context of Access. So if we have complex criteria that should be used with parameters as part of the definition for the view itself, it may not work that well because we cannot put any sort of dynamic parameters in this view creation here. And that is really where stored procedures come in very, very handy. Stored procedures are extremely powerful. They are, between stored procedures and pass-through queries, it's kind of the ace up our sleeve as far as, when we really run into a bind performance-wise, how can we resolve it? We'll try and do it using stored procedures, also known as procs, sprocs, stopros, and a bunch of different acronyms and names that we use for them. So they are strictly server-based, SQL Server. There's no equivalent in Access. There's no Access can't link to one of these. It's somewhat akin to writing code in VBA, and in the fact that it can be a set of procedural instructions that we're going to do. So a stored procedure on a server, unlike anything we can do with Access or unlike anything that Jet or Ace can handle, it can actually be somewhat of a procedural or a set-based type of process. We can process data on there. We can tell it to go update data. We can kind of run queries. We can actually even configure SQL Server itself through stored procedures if we have the correct permissions, so extremely powerful there. And or we can return records from these things. So if we have a very complex query that needs some parameters, we can send this code we can send the code from Access into our stored procedure and have it use those parameters to come up with a result set to send back to us. So it can act as a select query as well. It doesn't necessarily have to. We can do a lot of other things with it also, but that is another thing that it can do. So stored procedures are extremely powerful. You definitely want to spend some time getting used to them if you're not used to them yet. And they're a little bit more complex, especially if you're not used to using SQL Server, but you can kind of start small with them as well. So a procedure that you create is, the syntax for it isn't too bad depending on what you have to do. A very simple one here is, create a procedure, my procedure here with a parameter, and then we can just return some records from it. Very, very straightforward. We actually could have done that in a view just as efficiently without the parameter, but it serves to show how we would create a procedure. And this is a procedure that would return records. In contrast, over here we have another procedure that we could call that actually configures part of the server for us. We can grant permissions. We can create new users. We can restore a database. We can do all sorts of stuff with with stored procedures as long as we have the correct permissions to do so, which should also be an indicator of be careful with who you grant permissions to certain procedures on, because they are very, very powerful. In order to access in order to access these stored procedures, we're going to have to use pass-through queries for it, because there is no way to directly link to stored procedure access. Just doesn't really have the concept. So the pass-through query is the counterpart to this, and basically what it does is it says it tells ODBC driver to not bother trying to translate this at all. Just send send what I tell you directly to the server. Don't touch it, and let the server do whatever it's going to do from there. Very, very powerful. It allows us to tap into the server directly, so to speak, without having ODBC kind of get in the way. It's actually fairly simple to set up. If you open a new query in Access Designer, right-click in the blank canvas, select the SQL-specific type, and go to pass-through. And at that point, it will actually change so that you can only enter raw SQL into it, because there is no design interface really allowed to that. The only other thing that we should do is there is a property in there in the query properties to either it's called return records, and we can designate whether or not this particular query is going to return records or not. So those are the only two things that we need to do to set up a pass-through query within Access that can directly tap into a stored procedure that we have set up on SQL Server. Now, with that said, whatever SQL we write into this pass-through query has to be written in the T-SQL format, not in the Access format, because ODBC is not going to try and translate it at all. ODBC is going to pass it through itself without touching it and just let the server deal with it. So it must be valid transact SQL for SQL Server to understand. Now, with that said, usually what I will do is I'll do a one or maybe two template pass-through query objects. So if we create one of those and we set the SQL statement to select one, which just returns one bogus record that we don't care about, then I will use a VBA function to alter the query as required, so that instead of having a whole bunch of different saved pass-through queries for this type of thing, you can just have one of them that gets manipulated as required, and then we can call this VBA function from wherever in the application, because if we're going to be working with record sets like this, we're probably going to be calling it programmatically anyway. So we might have a public function sitting somewhere called maybe get via pass-through, and we send a SQL statement, and we're going to get a record set that gets returned. We'll pull up that query def object, say it's whatever we save it as. We'll change the SQL statement to what we were given, and then we'll tell it to open that record set and return it in the function. And it's very simple, very effective way to keep the clutter down as we're working on things in general, and it's pretty easy to use. The counterpart to that, this one would return records. The other one, if we just need to invoke some sort of action without returning records, we can we can do something like the second one I have here below, which is however we want to do it. We can tell it to execute this particular procedure with this branch ID and that branch ID, and we just go ahead and process it from there. So that is pass-through queries and how they are used to. Well, typically we use a pass-through query in order to call a stored procedure, but because the SQL being sent is raw SQL in the T-SQL format, in the SQL Server format, we can really send it anything we want that SQL Server will understand, but the most widely used case for this is to execute some sort of stored procedure or some sort of very complex query. And then when we start looking at how we can use that with complex data sources, it becomes hopefully fairly apparent that this is a very good candidate for coming up with complex data sets that we can use, because all of the processing, the heavy lifting, gets done on the server end of things, where it's very quick. The server is really optimized very well for doing that. We don't have to worry about ODBC tripping over its own feet, so to speak. So it's a very powerful technique that when used in conjunction with local caching and some of these other techniques that we've spoken about, between all these things together, we are getting to a point now where we can write an application that actually works as quickly as any other given application that's out there. Okay, we're going to move on here. I've got, I think I'm running a little bit over time, so if somebody needs to cut me off, feel free to do so, but I do have a couple other things I'd like to just touch base on, and I'm going to breeze through these very quickly here because I am running a little bit over. But we've got extra support with what I'll call database logic. Now, sometimes we might run into situations where if we had data in there that could help but wasn't necessarily part of the natural data set, as I'll call it. For example, when we run a Cartesian query based on a numbers table or a dates table, sometimes we'll start at the bottom and work our way up. And sometimes if we were just to store the last date that we had, for example, like a datum, and tell it to process only from there up, we can get much better performance out of things. So if we need to save a value to the remote server itself, some sort of metadata in order to help kind of just speed things along a little bit, it's not something that we may, it's something that we may have maybe frowned upon working on a LAN, but it can be extremely helpful as long as we don't really kind of overdo that type of stuff when we're working on a wide area network like this. So that's one thing that we can do aside from everything else we've discussed. To kind of help things along a little bit. One of the other things we can take a look at is persisted data versus dynamic results, and essentially boils down to how can we store calculated values to help performance if we're really kind of having trouble with a particular performance point. And a good example of this that I've used in the past is a pricing table. So a lot of times we'll have an associated table with it that says, as of this date, the price was this. As of some other date, the price was this. And when we want to go and query the current pricing, we need to pull in this other table to query it, and our query starts getting a little bit complex. It's not completely far-fetched at that point to say, well, 90% of the time I'm querying for the current values, and these values don't change all that often. So what if I were to have a nightly schedule that runs and queries these values and stores them directly into the single table that I really need to access? Would it be that bad? Now, we've learned over years of traditional style access development that we're not really supposed to do that type of stuff, but sometimes it can help a lot. Sometimes, even though it's not generally considered a best practice, it's something that we can do that can really help with performance in a case like this. And then maybe we'd run a nightly scheduled task to re-update those, and we should also have, as an escape route, so to speak, some sort of function in the application that we can tell it to, on demand, go ahead and refresh those values for us. So, for example, if we have some sort of administrative pricing set up, we should be able to, when we make some change to that, which isn't going to happen that often, but when we make some change to that, we should be able to say directly after that, go ahead and update our current pricing values now. So that's another thing that we can do in order to help with performance if need be. It's another thing that we should not do all the time, but it can help. Another thing that we may take a look at in certain situations is actually denormalizing the database and taking more of an OLAP approach to things rather than a transactional approach. One project that we are currently working on right now is very, very high in the analytics and very, very low on transactions. We don't write a lot of records, but we're constantly reading records. At that point, it might actually make sense to cut down on the number of normalized tables that are in there and put them into more of an OLAP style table, which can cut down on the query complexity very significantly. So if we have an application whose sole purpose is really just for analytics, it can be despite what we might have been taught for many, many years about doing database development, that this can be a very effective method to quickly analyze remote data. It could be a disaster if we have a highly transactional application. We certainly wouldn't want to do it in that case, but otherwise, it's another technique that we might want to pull out of our sleeve at some point in order to be able to do that. And another thing that we can do, one of the pain points that we haven't really actually touched base on is loading data into the server from the local end. So let's say somebody wants to upload a CSV file that has a bunch of different records in there. How can we quickly and effectively get that data from our local machine into the server, the opposite of caching, right? And that's actually a tough nut to crack because there's not really a good way to do it through record sets. We don't want to do a heterogeneous query because that's almost always really bad. We can open up two record sets, but writing into a server, unlike when we're using the cache and we're writing locally, which is very fast, when we're writing on a row-by-row basis into the server itself, that tends to be very slow. So when we need to do something like this, we can actually use, there is a native functionality in SQL Server for processing XML, and in later versions, I think 2014 and up, I believe, for processing JSON. In any case, we can take and build a large XML string with our data and process that through an ODB record set, which can handle up to 2 gigabytes worth of a string, I believe. So we can take a large amount of data, format it accordingly, send it off to the server, and have the server loaded up. It is not the most fun thing to program in the world, I will admit, and I'm not going to get into too many examples here, but if you do need to upload a lot of data to the server, it is a very, very efficient means in terms of processing processing to be able to do that. So that's something else that we can keep in mind. Stored procedures and bind parameters, as they're called. We have every time we run a query, well, every time a new query is run, we have an execution plan that is generated on the server, and this is actually, I believe, generated both on our Access end of things as well as on SQL Server, but we'll focus on SQL Server at the moment. So every time we run a new query on SQL Server, the query is analyzed before it's run to figure out what the database engine, what SQL Server thinks is going to be the most efficient way to come up with this, and this is the execution plan. So if we have if we have text that is different in the query itself, the execution plan is going to be reevaluated for each call. So this query here that we're looking at is almost identical to this query here. We just changed the parameter on it a little bit at the end, but we have these values kind of hard-coded in here. So technically the text for this query and this query are different. For a very simple query like this, it wouldn't be a big deal, but when you start getting into larger, more complex queries, the time it takes to come up with an execution plan can be something that we want to be aware of. And if it needs to do that every single time because we are hard coding values into a SQL string, we can do better than that. So if we come over to this end and we take a look at things, now we're going to use some SQL Server syntax. This is not stuff that you'll see in Access, so this is a good candidate for a pass-through query. We're going to declare a parameter. We're going to set that parameter to a value, and then we've got one SQL statement here which uses that parameter value, and we've got another SQL statement here which uses a different value. But because this text and this text, the actual query text itself, the instructions, are identical, even though we're putting in a different value in there, the text for the query is identical, so it'll go ahead and reuse that existing execution plan most of the time. And for very large and complex queries, that can be it doesn't usually make a huge difference, but sometimes you really need to squeeze it for all it's worth, so to speak. So this is a good way to if you get that far into it, that's something else that you can do. Besides all that performance related type of stuff, bind parameters are an extremely good habit to be in because they're much more secure. Basically, whether you're working with SQL Server itself or whether you're working with a .NET front end or a PHP website or something like that, in just about every platform for programming, except for Access, there is a way to do what they call these parameterized values, and essentially that cuts back on the ability for people to do SQL injection attacks, which is something that should never happen this day and age, but still does so often. It drives me nuts. But anyway, bind parameters and using bind parameters like that are very, very, very good hygiene. I highly recommend trying to do that if you are comfortable with SQL Server enough to do that type of stuff. Bind parameters are a very good thing. So I'm going to move on. I've got just a couple of slides left, actually really just one more slide left. And this is a little bit far-fetched, but it's something that we've done in the past. Sometimes, for more complex reasons, we may want to pull a remote database for changes. We might want to go to that database and say, maybe every 30 seconds, maybe every 2 minutes, maybe once an hour, maybe every 2 seconds. We want to ping that database and say, hey, has anything changed in this particular table? If so, let me get the stuff back in here locally so that our application can keep processing with the most up-to-date data that it has. Unfortunately, Access is and always has been a single-threaded application in terms of what we're allowed to interact with anyway. I believe under the scenes it does do some multi-threading work, but nothing that we're allowed to utilize from our end. If it was something that we could run async processing against, then it would be very nice to be able to say, hey, let's do a database poll every 30 seconds on a separate thread so that we're not tying up our Access application. People can go ahead and keep using it the way they're used to using it. It's a very powerful technique that is highly prevalent in other platforms except for Access. This is actually up until January of this year when I was still part of the MVP program, this is one of my common, hey, I would really, really like this feature for Access type of thing. But anyway, so the lack of ability to run async processing in Access is, it would be really nice to have. But we can get a little bit creative with how we want to do that. If we have our main application that's running over here on our local server, and we have a separate application which is basically just a bunch of a collection of cache tables that we're linked to here, we can actually fire up a third application over here, which would be responsible for going to the remote. This would have this would be the async processor, so to speak, that would check the database, the remote database, every 30 seconds or whatever schedule we want to put it on, and say, okay, when I find this data, I'm going to go ahead and update this thing here. And meanwhile, your main application isn't being tied up with, this processing request, which can take a long time. So this is also a good, maybe a good thing to use for running heavy queries as well as just polling. And then next time you refresh the record or something, you might see updated data accordingly because Access is reading the cache storage from there. So, and then if we want to go a little bit deeper, we can actually link these two up a little bit and send some commands to here, and we can actually get notifications back in here as well, but that's an entirely different, really kind of topic. With that said, if you did want to take a look, I actually did figure out a way to do that. I have a blog post on it here. You can take a look to figure out how to. There's an example, a downloadable template that you can figure out how to, you can take a look at how to run this type of async method within Access to be able to delegate certain tasks into the background so that you can still have a responsive Access application here. So I know I breezed through a lot of the end of that fairly quickly, and I'm sure it's not all 100% clear to you, but hopefully the presentation has been fairly enlightening in terms of how we might get decent performance out of this, and I'd like to see if anybody has any questions. I know I did skip over one of them for Phil, and I apologize. We can go back to that, or if anybody else has any other questions, will attempt to answer them the best I can.
Well, thank you very much, Jack.
Okay.
I have lost my little dialog box here, so I'm not seeing questions and comments as they come up. So.
Okay. Yeah, I had, like I said, there was one question from Phil that had come in that I was not able to address regarding the add new method on the. Bear with me for a second. I'm gonna jump back.
Jack, this is Phil. I was just curious when you did the add new. You said, that was almost simulating a rebar type of scenario. And I was curious, could you just use like an append query to do the same thing instead of, going through record by record?
Yeah, that's a good question actually, and I feel like I had tried that at one point, and what had happened was that I had came up with was a heterogeneous query that wanted to. I feel like ODBC wanted to try and analyze both ends of it in order to be able to do that, and as a result, it ended up being very slow because it had to do that. Whereas with this record set approach, there is no ODBC doesn't need to correlate those two sources at all. It's just a very straightforward, non-complex table read here, really. So it seems counterintuitive, especially for all the lack of phrasing that I have for trying to do things on a row-by-row basis. But in this particular scenario, it actually does work out very well because it is a very, very simple request that the ODBC driver needs to deal with. But when we start doing an append query, then it starts mixing up the source data with the target data, and things have a tendency to get pretty ugly at that point.
Okay. Fantastic. Well, I know this went longer than I was expecting, but just the right amount of time for me. I enjoyed every part of it very much. Thank you, Jack. I did
Well,
have one.
I'm glad, people seem to be happy with it. One more question that I have here. Any thoughts about software services that can replace Access web apps other than Power Apps for online databases? And unfortunately, I do not have a good answer for you on that. We ourselves, with my company, have moved into ASP.NET MVC development, which is not something that I would recommend for everybody, but that's what I've done. So because I kind of got sick of dealing with these less than perfect, I'll call them types of things here. So I'll leave it at that. I'd like to thank everybody for taking the time to listen to me prattle on about this, and hopefully everybody can come away with, or most people at least can come away with a little bit better, a little bit more confidence in how to deal with this type of stuff.
Yeah, great. That's perfect. Now, I think the recording of this session will be available on our website in a couple of days. So if you want to go over something that Jack said that you wanted to focus on more closely, you can go and see it there. I did want to make a couple of quick observations. One thing that struck me as I was listening to Jack is we are, as Access developers, frequently urged to do certain things the Access way. And one of the things that Access web apps sort of taught us was that sometimes you have to step outside of that box to get things done in a different environment. And very clearly here, some of the, what I think of as the shibboleths of our profession need to be carefully considered and sometimes rejected because the techniques that work really well in the Access world don't necessarily carry over. And so the one that I was thinking of when he was talking was caching local data, writing temp tables. That's a common technique that we often use, but not being afraid to do those kinds of things because they are actually more efficient. Caching the pricing table is the one that I was thinking of there. But don't be bound by old traditional ways of doing things when there's a more efficient way that you have to adopt to work in a different environment. So with that, I think our next couple of sessions will be sort of continuations of this discussion. I hope that we can have a fruitful question and answer session probably next month where Jack has agreed to come back, I believe. And Patrick, I think, is also willing to come back and talk, and I'll step in and share some of my thoughts. So in the meantime, if you have more specific questions about anything that we've talked about the last couple of sessions, or anything about Access web apps, the future of Access web apps, if you can start putting your thoughts together and preparing those questions, I think that'll be our next session. And after that, I think we'll probably want to start looking at alternative interfaces, which was the question that was just raised. Don't have anything specific lined up, but I think Power Apps will be definitely one of the things we want to see more on. And possibly some other development platforms that might be within reach for those of us who are not .NET developers. But that's kind of my short-term plan for the next 2 or 3 sessions. And so if you have thoughts or suggestions or comments, please pass them along so that we can start putting those into the pipeline and get them lined up to work on in the future. So with that, one more time, thank you to Jack. Thank you to everybody who attended. Thank you to Lucy for getting us going, keeping us going.